Hello, and welcome to today's webinar, Building a Layered Future, Resilient GNSS Alternatives that Complement and Not Compete with GPS, brought to you by GPS World Magazine and our sponsor of the event, NextNav. I'm Jessie Khalil from North Coast Media and GPS World Magazine, and I will be your event manager for today's presentation. At this time, I'd like to get you comfortable with your console and the ways you can participate during today's presentation. Please notice the Q&A panel on the side of your console. If you have any questions, type it in the panel's text box and then click Submit to place your questions in queue. We encourage you to ask or enter any questions you may have for our speakers during the presentation. Questions submitted during registration have already gone to our speakers and may be covered during the presentation. If you have any experience or if you are experiencing any technical difficulties during today's event, you may use the same Q&A panel on your screen to submit your issue, and our technical support assistants, Alicia and Hallie, will personally assist you. Finally, you may learn more about today's speakers by viewing their photo, bio, and contact information in the panel located in the upper right-hand corner of your console. Now, I'd like to introduce today's speakers. Admiral Rogers, you can go ahead.
Hey, thanks very much. So Mike Rogers, retired Navy 4-star. My last jobs, I was the director of the National Security Agency and the commander of U.S. Cyber Command, which meant I was running the largest intelligence organization in the government. One of our primary focus areas was trying to understand threats to space-based systems like GPS. At the same time, I was also a combatant commander, so I was very concerned about the operational operational implications of loss of capabilities like GPS. And then earlier in my career as a three-star, I commanded all of the U.S. Navy's assets in space. And I also, at one point in my career, ran a mission ground station for a space-based system. So I've spent a lot of time associated with space-based capabilities, if you will.
That's awesome. Thank you for joining us today. Diane, do you want to go?
Sure. Good. It's great to be with you, Jessie. Thanks for including me today. Diane Rinaldo. My career has spanned many different government agencies. I was in Congress and worked for the House Intelligence Committee. I was actually the NSA program monitor. I worked alongside Admiral Rogers when he was DIRNSA.
It's good to see you again, Diane.
Yeah, it's good to be back with you. And as we would say, supporting NSA was the only part of government that listens. So, but I went on from there and actually was the deputy and then the acting administrator of NTIA, the Tech and Telecom Agency for the federal government that had equities in space systems. And so I am pleased to be with you today to share some insights from my national security as well as commercial background in this area. So thank you.
Yeah, thank you. And Mariam?
Thank you, Jessie. Really excited to be here. I am Mariam Sorond, the CEO of NextNav. My background is primarily in telecom across mobile, satellite, and fixed networks. Super excited to be leading a company who is actually working on developing a ground-based positioning, navigation, and timing backup and complement to GPS. It's also great to be here with Admiral Rogers and Diane talking about this very important issue, which is a national security topic. Thank you.
Yeah, and again, thank you all for joining me. I'm really excited to kick off the panel today and talk about some really interesting topics and dive into different complementary systems. So I guess we'll start with Admiral Rogers. So you highlighted that there's some real world risk in an op-ed earlier this year published in the Dallas Morning News. In that, you wrote about a high profile jamming incident at the Dallas-Fort Worth airport. So as the retired admiral and former leader of both the NSA and the US Cyber Command, what is at stake from your perspective?
So we have created an incredibly complicated system from our economic models to the way we run our transportation system like airports, to the way we ensure knowledge in our everyday lives about exactly where we are on the face of the earth. And That knowledge, that ability to generate precise information with high confidence as to exactly where we are, enables us to do things like put lots of different airplanes into pretty tight space because we got confidence that we know where everything is. We feel confident that we can operate closely and yet have an acceptable level of risk. You saw that in the Dallas airport event, where the concern became, if you're losing the ability to know precisely where you are, it's no longer safe to be operating aircraft together in close proximity. So the decision was made, hey, let's potentially shut down the airport. You start to see the cascading economic, the cascading national security, and then just in our everyday lives. You know, I'm sure there were thousands of people that day who were either at the airport or heading to the airport because they had a specific flight at a specific time. They were going on a vacation. They were going on a business trip. They were going to see family. They were dealing with a medical emergency. And all of that gets disrupted. So it's not only economic and national security, but our entire lives are built around this concept of we always know where we are. Think about the last example I give you. This always strikes me. I don't know about our audience, but I hardly go anywhere anymore without using a digital app in which I physically know where I am and I align that to where I'm trying to go. And that enables me as a driver, as a passenger, to make smart decisions. Imagine if we lost that and you're trying to figure out, if I don't know where I am, how do I know how I'm going to get to where I want to be? And we just take this for granted these days.
So now that we're seeing in Europe and the Middle East in terms of navigational warfare, jamming and spoofing, like we kind of were just saying, it's impacting navigation, civilian and defense side. What kind of impact is it having on policymakers in the US?
So I'll give you a military perspective, but you're going to want to hear from Mariam and Diane. Look, from a military perspective, think about the fact that all of our weapon systems are based on the ability to use precise navigational inputs to achieve precise effects on precise targets. We've developed this over the last 40 years since we created GPS, and first started launching satellites into orbit for GPS in the late 1970s. And if we lose that, and it starts to impact our ability to conduct military activities like weapons, like if you're a ship, oftentimes, to demonstrate fundamental issues like freedom of navigation, we will ensure that we know precisely where we are as we are operating close to the coast of a nation, trying to remind them that under international law, we have the right to do that. Imagine the implications if you're not sure exactly where you are. You don't want to be, for example, messing close to the coast of Russia and China if you don't have precise knowledge of exactly where you are in relation to international territorial waters, standoff distances. It's just amazing to me. This has become so ubiquitous. It is so ingrained in everything we do, economically, national security wise. We just take for granted that we're able to do this. And we haven't really had to deal with, well, what happens if that's not true? And increasingly, you're starting to see real world examples of where that is no longer true, where the capability is being denied. And we're all trying to figure out, so if this is going to become the norm, if we're going to see more disruption, if we're going to see adversaries who realize how important this precise navigation capability is to us, and so they're going to disrupt it, they're going to deny it, they're going to try to degrade it. We need to ask ourselves, what does that mean for us? And how do we come up with a strategy to mitigate this vulnerability?
Absolutely. I think Admiral Rogers, I always love listening to, and it's so amazing that that our government is very aware of this issue. They're working on it. They're working on it outside of our borders. And then, we also have our inside of the borders problem. One of the solutions that we're working on is looking at inside of the borders. But that's informed by what's happening outside of the borders, right? Because that's when we're seeing in the wars and the conflict areas and what our adversaries are using is really informing us, what if this is brought back home? Okay, what if this happens back home? And like Admiral Rogers pointed out, what if somebody decides to go after a very weak point in a conflict situation? And this is where I get so many emails on a daily basis of all the incidents, and whether that's our employees, board members, external, to say, hey, have you seen this? Have you seen that? It is this number of incidents that are increasing, that are public, that are coming through public media, right? Not just necessarily what we don't know about, that could be going on in any of these conflict areas, is incredible. It's an issue that, first of all, I get super excited about being a part of the solution and having something that offers a solution within a system of systems. I get passionate around it, but this problem statement really needs to be addressed, and we're kind of running out of time. That's what we really need to do, is move along urgently all solutions, any solutions that are out there to address it.
Yeah, and if I could just add on top of the comments, what we're seeing right now are flags. It's incumbent upon us here and policymakers to take advantage of those flags and things that we can do. There is movement, but we need to make sure that that we're able to continue through with that movement into actual policy that can be acted upon. We have GPS. It is a great tool, but it is a single point of failure. We need to start thinking about how can we build a more resilient PNT system.
And going off of that, so Admiral Rogers, if you can add some insight onto this. So there's multiple presidential administrations, government agencies, members of Congress, the military, and even industry. They've recognized and warned that America's over-reliance on space-based GPS signals leaves us exposed to all these vulnerabilities. What is the risk for each of your vantage points, and why has solving this vulnerability been such a difficult task from each of your perspectives? Yeah.
So for me, I would argue the challenges are, number one, the scale. We use this capability literally everywhere around the globe. So the scale is massive. This is not a problem set where, well, all we have to do is worry about a segment of the United States, or all we have to worry about are areas around particularly sensitive, potential competitors or adversaries, Iran, China, Russia, as examples. What you're finding is we're seeing impacts on our current architecture everywhere, to include within our own territorial space, which you saw the Dallas example I tried to highlight in that op-ed piece. The second thing I would highlight is one of the things I think we need to be mindful of, we need to think about multiple solutions here. I think there's an RF component to this that uses existing infrastructure that's already in place. So we save a lot of money, we save a lot of time. How can we maximize investments that have already been made? I think there's a component to this about other alternatives to the space-based component of this as, again, a secondary or fallback. All of this is complicated. All of this takes time, and all of it significantly involves government policy and government regulation. You just don't unilaterally, as a private sector, make changes to this system. Mm-hmm. The way it works, it is like GPS satellites. Hey, they are owned and operated by the government. This is not a commercial entity, a private sector entity that provides this service for a fee. The government decided this is so foundational to the nation's security, both from a traditional national security perspective, but also an economic security perspective, that the government felt there was merit in using taxpayer resources to create a global capability here that the government could assure sustained its functionality, which is why government runs replacing satellites, etc. But that also means there's a lot more complexity. I wish I could tell you that this would be really easy and really quick, but it just isn't going to be, and it hasn't been so far. But to the point that Diane made, we're quickly getting to the point where we are running out of time. We have just got to implement a handful, to me, of specific techniques that will mitigate the risk here, because it's only the if to me, not the when. we are going to see degradation to the GPS system, and we're going to see it at times on a very broad, almost global basis. I mean, I can think of scenarios where you can have global impact, if you will, not just localized, RF kind of jamming things, but you really could see much broader global or regional impact.
Exactly. I mean, GPS is, let me just say, an amazing technology. American made, it's a national treasure. It is. It really is. How it started and where it is today at the scale that Admiral Rogers was talking about is incredible. Our everyday lives, military, all future of warfare. And the scale of this really right now is why we're talking about not really a replacement of it, but in my view, it's more about building resilient layers into it, right? You can't, I don't, it's not possible to replace GPS. It's amazing. It works. It's a great technology. It works to the extent of what it is, satellite-based system, and it includes some vulnerabilities. The resilient layers that you need to build into this are what the Department of Transportation described as a system of systems. Basically, there can't be just a single solution, right? You need resiliency on the satellite layer, you need resiliency on the ground layer, and there's multiple different resilient layers that you need to build for this. So that's what the scale he's talking about is that, think about this multi-system, multi-level, resilient nature to overcome the vulnerabilities. Now, what are the vulnerabilities? They are the fact that satellites themselves are vulnerable, but also by the time their signals get to Earth, they become weak, so they become susceptible to spoofing, to jamming, and whether it's intentional or unintentional, we get a lot of unintentional jamming here in the United States. So they also have a problem in urban canyons and indoors. You can't get satellite signals indoors in urban canyons. I'm sure anyone who's trying to get a cab in New York City in a dense area would realize this, that it's not very accurate. So this is the resilient building and overcoming its vulnerabilities that are a massive scale that need to be looked at. You're on mute.
Diane, you're on mute.
Gosh, I've only been at this for 5 years, right?
We gotta have this happen at least once every webinar. Come.
So I was just going to add, PNT is not so unique that we've seen this in multiple different issue areas, whether it be cyber and telecom and supply chain. Since we've moved from the analog into the digital space, there no longer exists the silver bullet. And so I think with policymakers, they still kind of want to find that silver bullet and that one answer that's going to solve it all, and it just doesn't exist anymore. So that's why it's so incredibly important to kind of get people, re-educate into people on, sorry, my dog's barking. I'm struggling today. To re-educate people on that it's important to, in order to build a resilient system, that you need many different options. And so I know I've done some work on Capitol Hill, and I recently did an event. And so that's one thing that I've been working on, is just better educating policymakers on the importance of, all of the above.
Hey, can I make one comment? Because the two comments you heard from Mariam and Diane bring this out to me. As we're trying to figure out solutions, the thing that I always try to remember as a military guy was, give me solutions that give me speed that I can implement relatively quickly, scale, give me solutions that I can implement broadly so I'm not doing a million one-offs. And then lastly, how can I try to maximize cost and efficiency? Hey, is there existing infrastructure that I can tie into so that rather than create an entire alternative structure, I am maximizing the use of existing sunk costs, existing infrastructure, existing investments? I mean, because you have to be mindful, if the goal was to replace the GPS, the cost, for example, to replace the GPS system with something totally new, I would argue that is so cost prohibitive that it's just not a realistic scenario to me, particularly if you're going to do it quickly or you're going to do it at a reasonable cost. That's just not a realistic option. So the answer to me becomes, so what are the ways that you can come up with mitigations that give you more resiliency without walking away from the billions of dollars of investment we've made in the current infrastructure.
So, Diane, earlier this year, the FCC chair, Brendan Carr, he issued the NOI seeking comments on systems that can help complement and back up GPS. Why is that engagement so important, and what are the next steps in the process?
So I will say that Chairman Carr's leadership in launching this NOI has been a watershed moment for the FCC. The FCC hasn't, in a meaningful way, looked at this issue in more than 20 years. And so I would say the next step is moving from an NOI to a rulemaking. And so I know that they are doing their due diligence and meeting with organizations. Chairman Carr has proven himself to be a leadership in this area, kind of getting out there against foreign adversaries, unlike any other chairman has done before. So I'm confident that this is moving in a positive direction.
That's awesome. And considering the critical dependence on global infrastructure like transportation, finance, energy, for a shirt on PNT, what is the optimal architecture and governance framework for integrating complementary PNT systems like 5G positioning reference signals, BPS, optical clocks, low Earth orbit, non-GNSS constellations with GPS, such as the resulting layered resilience, specifically addressed in both cyber-physical security vulnerabilities, like jamming and spoofing?
Mm-hmm. Well, as you've heard over the past 20 minutes, I think we are all in wild agreement that you need a layered hybrid system to complement GPS. As a 5G person, I am biased. I think, for the past 5 years, people have been saying, what is the great use case for for 5G? And I really think it could be this, PNT, in national security, with low latency, high bandwidth. It really has the opportunity to move the ball in a space. So I'm really excited about what NextNav's doing and how it's going to really impact our national security here in the United States.
Yeah, I think you heard Admiral Rogers say speed, scale, and efficiency, right? And I think that ties really well into a 5G based architecture. That the speed is basically you get a footprint that has density that is terrestrial for a ground-based complement. So basically, when you deploy this, you'll have the scale of that terrestrial network, the speed. Operators add spectrum and capabilities and signals to their existing networks really quickly. It could be done in this administration, and also the efficiency of it, where it's a market-based solution. It's not requiring taxpayer dollars. That is incredible, and this is why Diane is exactly right. For years, people have been talking about what's the killer app for 5G? What's the incredible use case? There you go. Here's a use case for 5G that addresses a national security issue.
The other thing I think that's also really interesting about 5G, particularly in dense urban environments, the technology is optimized to provide coverage within those physical characteristics of an area, like the canyons, loss of direct signal path. 5G was designed in part to compensate for some of those physical challenges about signal access in dense urban environments. So you've got a technical solution in some ways that you can build off of that's really optimized in some ways compared to its predecessors, 4G and 3G. In dense urban areas. And the other good thing is, look, 5G is becoming ubiquitous. It is becoming the standard baseline now for our backbone, mobile systems. And so it is becoming the baseline standard now. And we've been deploying it now for, a good 5 solid years at a high industrial rate. So the amount of infrastructure that's out there, plus the infrastructure that's being put in, for 5G is really attractive because industry's already made the bet on 5G. You're not asking industry to change market dynamics. You're not asking industry to come up with a solution that isn't in place.
That's a great point.
Mariam, the next question's for you. What role does the private sector play in helping solve these challenges? And how would NextNav's proposed solution work to complement and back up GPS? What types of investments and partnerships are needed to drive the innovation? And then how quickly could this happen once you have the FCC approval?
I think I'm a big fan of market-based solutions, right? And the reason is when you can solve a problem such as this without taxpayer dollars, without government funding, and also think about the other advantages that basically market-based solutions bring. They upgrade, they're future-proof, they kind of go through the cycles. One of the things about 5G, it's future-proofed, right? If you do a ground-based PNT solution in a 5G network, it will just kind of go through the evolutions of 6G and 7G by itself. So, and it relies on economies of scale for 5G. It's fast, it's efficient, the industry can do things, but faster. Right now, the problem statement over here, and going back to the scale and the importance of this issue, is that GPS is a free service. And so you'd ask, why have there not been market-based solutions so far to address this? It's because you have to deploy a terrestrial-based network for the ground complement, basically competing with a free service, which is GPS. Okay, so there needs to be creative solutions around this. And by the way, there's a lot of other technologies that are ground-based as well. And as you mentioned, there's the broadcasters, there's ELORAN, there's multiple others I sometimes don't name because I don't want to leave anyone out. I'm a big believer that all the technologies play a role. I'm a big believer that this is a system of systems, as the Department of Transportation described it. But there you go. I called out a few as an example that are out there. And so all of these either need government funding, right, or need to get creative around how do we make this market-based when you have to compete with the free service. So what NextNav's done is basically we have licenses in the 900 megahertz spectrum. It's low band. It actually works really well indoors. It's ideal for 5G. Low band continues to be very much needed spectrum and always a finite resource. So basically, riding on those, we can enable a terrestrial-based solution where an operator deploys this spectrum into their networks, and then we take an existing signal that you turn on in 5G called the PRS signal. It's standards-based. You don't need modifications, any modifications to the 5G technology. We turn this on, and it's our software that actually extracts multilateral rates, does the positioning and timing extraction out of this signal. So it's solving really a couple of problems. You're putting 15 megahertz of spectrum to use through 5G and broadband, and also you're taking the sliver off of the top of it to put a ground-based complement and backup terrestrial network to GPS.
So actually kind of going off of that, are you seeking to have the FCC modernize your license and not filing for a new one, correct?
Correct. We
Okay.
have existing licenses in the spectrum band, and I know that that's an important fact to talk about. And I would say exactly, it's modernization. It's also the modifications or the optimization rather that we're asking for is very minor compared to a lot of the spectrum rebanding requests that have been in front of the FCC for the past decades. We understand that, you know, whenever you ask for changes, people don't like change. So there's folks that are talking about how this issue could impact them. But what we have presented to the FCC is engineering-based technical data that shows how everybody could continue to operate in the 900 megahertz band while we're addressing a national security problem, that others continue to operate there without impact. So I would call it really minor modifications or optimization to the existing licenses.
So will there be any impact of existing licensed and unlicensed 900 megahertz users in the FCC move or forward to reconfigure the band? And then how will you ensure that minimal disruptions to current operators will occur?
Yeah. So you can't come in a band and say, you're gonna be impacted and nothing can be done, and that's not at all what we're doing. There's multiple tiers of users in this band. One of them are the licensed users, which are the tolls and the railroads. We're working with the railroads and with the tolls. There will be some impact to them, which requires retuning of their operations. It is not a rip and replace. You do not need to replace any hardware. You actually really just software changes to the network allow for them to change their frequencies down. Of course, in these cases, we've definitely signed up for paying the cost of this minimal impact to the toll operations. And with the unlicensed in the band, they don't need any relocation. They can continue to operate in the band, and we've demonstrated that there's not impact to these operations.
So my next question is for Diane. We've talked about the benefits of 5G during the webinar. Were there any specific benefits that you have some insights on, or anything that you feel like you could share about the potential benefits of 5G for PNT?
Yeah, so when you leverage 5G, you're going to be able to accelerate deployment, and it's going to be at a lower cost. You don't have to dig any new ditches or trenches or put up any new towers. These things already exist. And so you're going to have dense connectivity, low latency to power the systems. You're also going to be able to help our current ISPs and their day-to-day activities. And what we've seen is that ISPs are actually going out and starting to build new relationships because they also understand the need to create resiliency. And so what this will do is this will help our emergency systems. This will help empower future autonomous vehicles. Right, so everyone thought that 5G would lead to autonomous vehicles. I have a Tesla. The self-driving feature is absolutely amazing. But what we'll see as we move further and further along is that these things will become more ubiquitous. And the moves that we do now and today are going to really help innovation push these things forward in the future.
And Mariam, can you tell us a little bit about the NextNav journey and how the benefits of 5G can enhance your current complementary PNT service and offerings?
I think Diane covered it well. Basically, we will be partnering with an existing mobile operator to deploy this network, which is why it becomes a very efficient model, right? I mean, if you think about it, any ground-based network is going to need terrestrial towers. Any ground-based complement and backup to GPS is going to need terrestrial towers. What better infrastructure than the 5G infrastructure that has the density, that needs to continue to add spectrum to grow its capacity to carry this. So we will be partnering with a mobile operator. We are not going to build a from scratch network. And basically we will be using what's existing in the standards to deliver the solution from a positioning and timing perspective. So it goes back to, and I'm going to repeat this because I love it, from Admiral Rogers' perspective, who understands and knows this problem really well. It is the speed, the scale, and the efficiency.
Hey, and Miriam, you bring out another thought to me about one of the keys here is going to be maximizing the efficiency of spectrum. That is such a spectrum is so contested in the sense that there's so many competing requirements for spectrum today, and this has become such a political issue that one of the things that's attractive as you're looking at solutions is how can we do this in a way that maximizes spectrum and minimizes disruption within existing spectrum constructs? Because, oh man, trust me, this gets so complicated. So the idea that a solution really maximizes spectrum with minimal disruption, I'm like, that is very powerful in the world of RF that we're living in today.
Exactly, and especially spectrum in a band where there's not any more of it left, right? If you look at the one big beautiful bill that required freeing up spectrum, the range starts at above 1.3 gigahertz, and there's a reason for that, is because below 1.3 gigahertz there's a lot of federal operations in the band, and there's no way that I can imagine our government really giving up any of these airwaves, because they're extremely valuable. Again, the propagation characteristics of low band and indoor and for coverage purposes cannot be met by mid-band or above, while mid-band and above brings incredible capacity and speed to the networks. So, but coverage will always be solved by low band. So now you're talking about a 10 plus 5 megahertz block in a region, and as you were pointing out, you're making this efficient in a region where there's not any more spectrum left. And we have to do this in a way that it is minimal impact. And I know you asked me this question, but I just wanted to reiterate that that's what the FCC, and as Diane pointed out, we're super excited about the FCC moving this forward and providing this whole of government approach to solving a national security problem, right? The DOT, the FCC, you need everyone, the White House, everyone to come together and really do their part, and everybody is doing that between the Department of Transportation and the FCC to say, hey, what can I do to move the ball forward on it? And it's what the FCC does best, is when there are requests for spectrum optimization, they have the engineers, they have the expertise to determine that is there going to be an impact or not. And so we are very encouraged by the FCC moving forward to the next step, which is issuing a notice of proposal rulemaking to be able to just to figure this out.
So I have a question for you, Admiral. So China and Russia both have terrestrial systems to back up GPS. How does this make us vulnerable? We've kind of touched on it earlier. And then what can we learn from our adversaries interested in ground-based alternatives?
So clearly, when you look at China and Russia, they have decided that they need to develop a formal mitigation strategy, and that has a significant ground-based approach to it. They did not decide to replicate on-orbit capability. They decided that the best backups for them were largely ground-based scenarios. So they clearly have are thinking about some of the things we've addressed today as they're trying to figure out their own best way to do it. The other thing I think is you can already see how nations and even groups look, for example, to do local jamming and local spoofing. That doesn't take a nation state to do. There's commercial technology that is readily available. You can reorient and reuse existing RF, for example, using pretty simple techniques to just create interference, to just create disruption. So the question here is this difficult to do? Is this something really we should be concerned about? Hey, I understand it might be technically feasible to disrupt GPS, but is this really realistic? And could they really do this at scale in terms of breadth of geography as well as potentially duration? Hey, and the short answer is yes, yes, yes. It's readily available to do that. So as we've watched other nations develop mitigation strategies, clearly we need to do the same. And I also remind people, look, that as we're thinking about mitigation strategies, remember that, as we've said previously, we want to think about multiple layers here. This is so foundational that I think we want to do multiple. And secondly, think about the RF component in this, in the sense that when we think about how you disrupt a GPS system, we generally always focus on the RF piece as, well, you just jam, you just spoof. And I'm going, if you look at the spectrum of capability out there, you can jam, you can spoof in terms of the downlink, the RF of the signal itself that's relaying the geographic positional data. You can attempt to interfere with the satellite's ability to actually generate the solution, if you will, let alone actually downlink it. You can go after, remember, all those satellites on orbit have ground-based segments that do mission control, oversight, that actually do the maintenance operation of the satellites. You can go after the mission ground system. As I said in my introduction, I actually ran a mission ground station for a national overhead system, a space-based system. And I can remember telling the team, hey, we are so focused about what an adversary might do to us on orbit. Guys, between us and that road right outside our base is a chain link fence. This isn't really hard for an adversary to get through a chain link fence, for example, whether they want to go after our power supply, our ability to sustain our activities, whether they want to specifically attempt to do physical disruption. I just urge people, as we consider the spectrum of possible ways to disrupt GPS and precision navigation and timing, there are a whole lot of options out there, and therefore we need to have a pretty open mind about what are the handful of mitigation strategies that are going to be the most effective. Now, I believe ground-based RF is going to be one of the cores, because as we have said previously, I just think it has so many advantages going for it, and it gets you to that speed, scale, and efficiency. It's probably the fastest, the largest scale, and the cheapest, I would argue, alternative to do it. But I do think that we need to remember there's lots of ways to disrupt this capacity and capability.
Yeah,
Going on. Oh, go ahead. Go
No, I
ahead.
was going to say, absolutely right. And I'm going to steal a quote here. You want to fix your roof when the sun is shining, right? You do not want to wait for all of this to happen. And besides the RF capabilities, so the spoofing incidents, and this is with respect to one of our allies in the Middle East who spoofed its own network. I mean, just think about it. They spoofed their own positioning network to basically throw off guided munitions towards their country, right? People, this is an article out there for folks to read. People woke up in Tel Aviv one day and their maps showed them to be in the middle of Beirut. And this was Israel spoofing its own system to be able to defend itself. We don't want to be in those situations, right? We're trying to prevent being in the situations. While, of course, spoofing and jamming is happening today in the United States, it's not a what if, it's happening right now. But you also want to prevent something like that and having to do something like that in the future.
So kind of going off of that, we've discussed what's at risk on a global scale, national scale in the US. If something does happen to GPS, if there is a signal outage, if there is a large enough disruption. Admiral Rogers, what are some of the vulnerabilities for a global outage of GPS? Typically, all the interference is local, like we were saying, originally from jammers and ground-based radio equipment. Is there a threat vector which is global in nature?
Yeah, so if I was trying to have if I was an adversary and I was looking and saying to myself, how might I have global impact on the GPS architecture? I would be thinking about things like, could I use cyber as a tool to have global or nationwide outages in terms of ability to control, ability to collect and downlink? Because remember, those are all automated highly networked functions. They just don't happen, without a level of a control system. So I would look at cyber as a tool potentially. There's a handful of mission ground sites associated with operation, for example, of the constellation. I would look at how could I disrupt, isolate, damage potentially some of those capabilities, some of those physical downlink sites, if you will. You could ask yourself, how might an adversary be able to create damage on orbit to the satellites themselves? That's harder, and right now, largely only nation states are capable of doing that, and really only a handful of nation states. But we do have nation states out there, China, Russia come to mind, who have developed on-orbit capabilities to destroy on-orbit or damage on-orbit satellite systems. Another thing that becomes an interesting scenario, well, what if you were able to potentially reconfigure some of the constellations? Because the constellation architecture is all based on precise orientation and location of the satellites on orbit with each other, as well as field of view and coverage. What if you were able, for example, to physically disrupt that? What if you were able to disrupt that via RF? Now, that would be RF's a little challenge just because these are mid-Earth orbit. These aren't the low end. These are satellites. They're not at, geosynchronous 22,000 mile, 26,000 mile orbits, but they're at mid levels. So that makes them a little harder, but we shouldn't think that they're beyond reach. Nobody should think that on-orbit constellations are beyond reach.
And I think we have time for one more question. I will direct this one to Mariam and Diane, but Admiral, of course, if you have some things to add, then please do. So we have a lot of readers that are interested in the possibility of adding PNT signals to commercial TV or FM broadcasts. How do you guys see the implementation, benefits, pros, cons, things like that of integrating this system? Can it be done? Has it been done successfully? Stuff like that.
So I think the broadcasters, they have a technology called BPS, and it is the intention is to use the broadcast frequencies to be able to deliver PNT. I'm not an expert on the technology, but I would recommend to look that up and talk to them about it. And again, that's why I say this is a system of systems, and many different entities need to come together to solve this problem. So the broadcasters would be great. The characteristics of a broadcast network are they've got very tall towers, they're wide area coverage, higher power than cellular, which has its benefits in terms of potentially some timing aspect and providing timing aspects. Now, of course, cellular networks are more dense, so they have more sites, and more density is what's sometimes required to be able to provide more accurate positioning, because you're multilaterating to be able to find a position, and so it offers a different solution. So again, everybody brings a different solution to the table based on the characteristics of networks that they have, but there's definitely BPS in development, and I'm sure there's a lot of information there to look up into whether it's the NIB or any of the broadcasters who are providing the solution.
Perfect.
And I'll just
Go
quickly
ahead.
add on top of that. We've been talking for the past hour, the need for a layered approach. I just think it's important. Kind of our next step is that we really focus on density, and we really focus on kind of layering the United States in a terrestrial. And I think 5G is the next step. Is that answer, and then we see what holes exist and go from there. So it's a less scattered approach, more systematic.
So this can be the last one, but I just had a really quick point, because we have been talking about the need for an all of government approach to solving all of these problems. is there a kind of picture that we could paint of what that would look like in practice?
I mean, from my perspective, I would argue, and Diane certainly dealt with this. The nice thing is we actually have a government structure that is in place to address these kinds of issues. And, the FCC plays a key role here, and the process is designed to incorporate the viewpoints of multiple perspectives, from the military and national security to the economic implications of vendors and customers, to the ability to provide comment and perspective from consumers, from potential users of the system. So to me, the challenge isn't that we don't have a process or a structure. The challenge becomes who's going to take the lead and synchronize all of this and do it in an aggressive manner that gets us down the road actually doing something here. Now, and the good thing is you're seeing some signs of that, I would argue, from the SEC, and I would argue that's a great thing for us. The key now is, hey, we've got the initial steps, but we got to take this all the way through to actual execution.
Yes, agreed. NTIA does this through their IRAC system. They manage federal spectrum. They have all the agencies with jurisdictions at the table. So something really similar could be set up for this. There are lots of different equities in the government. And so I think that this is an easy problem to solve.
Exactly. I mean, just going back, this problem was identified basically by both President Trump during his first administration through an executive order 13905 about needing complement and backup to GPS, right? And subsequent to that, the Department of Transportation has undertaken, basically acting on that executive order, and they've been doing a lot of good work. In addition, Senator Cruz and Senator Markey together have also been really supportive and also involved with driving the multiple agencies across getting to a solution to this. I think the Department of War is also, of course, outside of our borders as well, doing incredible work to come up with solutions in the conflict areas that help us and help our allies. And then the FCC, I think, is incredible, where they jumped in and they said, hey, I have a part and I have a role to play in this as well, and they're doing their part and role, and Chairman Carr has been doing it on incredible speed. So these are just some of the examples of what the all-of-government approach means and to solve this national security problem. And NextNav is super grateful and thankful to every one of these agencies that I mentioned. And of course, really wanted to highlight President Trump, who issued this executive order in his first term.
Was there anything else that you guys wanted to add before we wrap up the webinar?
I guess for me, the only thing I would add is there are challenges here, but this is not as hard as we think it is.
Mm-hmm.
My view is the difficulty here isn't the technical dimensions of this. The difficulty here is the policy and the process dimensions of this, because you got to get bureaucracies to act, and that isn't always easy.
I think that's a really good point that you mentioned, is finding somebody to kind of spearhead this and take control of all these different systems, like create this system of systems approach and implement it and set some standards for everybody and integrate it. I think that's a really good point, that because, we look at Galileo and some of the other satellite systems and the advancements that the other countries have made to their system. And GPS, we haven't had all of those updates, but we have plenty of other terrestrial options, RF, aileron, LEO system, LEO, MEO satellites, and 5G that can help us out in the US. So I think those are all really great options to explore. And I'm really, thank you guys for the excellent discussion and sharing your insights today. It was excellent and plenty of valuable perspectives were shared today. So thank you.